Hello everybody, welcome back to Engineering Economics Analysis. On this video, we will uh, talk about the incremental analysis. So in order to explain the concept of incremental analysis, I will use example number one. And based on the example number one, we have two investment alternative. Investment number one, we call it as the LISCO, and investment number two is the Selco, and we want to decide which one that we will choose. So based on the example number one, I have the following cash flow. So this is the cash flow for LISCO, and this is the cash flow for Selco. 3,000, it is just the total of the cash flow of LISCO, so it is just a simple total. And 3,217, it is just the total of the cash flow of Selco. So the S minus L is the cash flow of Selco minus the cash flow of LISCO. Why S minus L? Because the total of S is bigger than the total of L. Now, in incremental analysis, when we want to decide which alternative that we want to choose, so we need to consider the MARR. So MARR, it means minimum attractive rate of return. So basically the MARR, it is the least value of rate of return that we want from an investment. I repeat, MARR, it is the lowest value of rate of return on an investment that we want to have. So for example, if the MARR is 5% per year, that means at least we want to have 5% per year return from an investment. Now I will calculate the net present worth for alternative L, the net present worth for alternative S, and the net present worth of S minus L, and I will calculate that at various values of MARR. So here from 0 until 16%, and then I will plot the net present worth of L, the NPW of S, and the NPW of S minus L, and the plot is the following. And as you can see that the dashed line is the NPW of S, the solid line is the NPW of L. So the NPW of L and the NPW of S intersect at MARR equal, that is about 8%. So intersection point is at MARR equal 8%, and also at 8%, the cash flow, the NPW of S minus L intersect with NPW equals 0. So the 8%, we call that as the delta IRR. So the delta IRR means the value of IRR when the alternative have the same value of IRR. So that is the delta IRR. I repeat, delta IRR is the value of IRR when the alternative have the same value of IRR. So, from IRR equals 0 until 8%, so we will have delta IRR bigger than MERR. So from 8% till 100%, for example, so we will have delta IRR less than MERR. Why? From 8% until a value that is bigger than 8%, we have delta IRR is less than MERR, because see the NPW line of S minus L, it will give that is showing us a negative NPW of S minus L. So I copy this chart into my my PowerPoint presentation. So this is the same chart. So from 0 to 8%, the delta IRR bigger than MERR. When it is bigger than 8%, we will have delta IRR less than MERR. So in conclusion, so when the delta IRR bigger than MERR, we will choose alternative S. But when delta IRR is less than MERR, we will choose alternative L. So if we come back, S have a higher total, because if you compare the total of the cash flow of S with the total of the cash flow of L, so the total cash flow of S is bigger than L. So in conclusion, so if delta IRR is bigger than or equal to MERR, select an alternative with a higher total. Otherwise, so that means delta IRR is less than MERR, select an alternative with a lower total. Okay, so that's the conclusion that we have from the incremental analysis. So so in order to choose what kind of alternative that we will choose, so we need to calculate the delta IRR. So in order to calculate the delta IRR, we need to use the concept that we have learned when we are discussing the rate of return analysis. So maybe you will need to do interpolation, maybe you will need to do trial and error, and then after that also doing interpolation. But we can also choose an alternative without calculating the delta IRR. So we can also choose an alternative without comparing delta IRR with MERR. So because we are comparing delta IRR with MERR, that means we need to calculate delta IRR first. So there is a other way that we can do without calculating the delta IRR. So the thing that we can do is by using the net present worth, the NPW of the difference between the alternatives. So in this example, it will be the difference between S minus L. So why S minus L? Because S has a higher total comparing to L. So we calculate the NPW of S minus L at MARR that we want. Okay. So when you have NPW of S minus L at MARR bigger than 0, we choose alternative S. Otherwise, when NPW of S minus L at MARR less than 0, we choose alternative L. So this is the easiest way when we are doing the incremental analysis. We just use the difference of the cash flow and we evaluate the NPW at MARR. So when the NPW at MARR is positive, so we choose an alternative having a higher total. So when we have NPW at MARR less than 0 or negative, then we need to choose an alternative with the lower total. So this is higher total, so this is lower total. Okay. Now in order to make it more clear, I will use two examples. I will choose example number example number 6. So we have 5 alternatives: alternative A, B, C, D, and E, and each alternative has the useful life of 20 years. And the MARR, the minimum attractive rate of return that we want, is 6%. Okay, so I will copy the cash flow into Excel, so it is easier for me to calculate. Okay, so we have alternative A, B, C, D, E. This is the year. This is year 0. And this is year 1 till year 20. Sorry, should be 1 till 20. Okay, so A, the cost is 4,000, so that's mean minus 4,000 because it is cost. B, minus 2,000, it is a minus because it is a cost. C, minus 6,000. D, minus 1,000, and E, minus 9,000. And the cash flow from year 1 till year 20, it is 639 for A, 410 for B, 761 for C, 117 for D, and then 785 for E. So the first thing that we need to do is to calculate the total of the cash flow. So total is just a simple total. So this will be minus 4,000 plus 20 times the cash flow. Okay. So that is the total cash flow. So the thing that we need to do now is to compare each alternative one by one. We start from comparing A and B. So now we will do the incremental analysis for A and B. See, the total of A is bigger than the total of B. So we will calculate the cash flow of A minus B. Okay. So it is year 0, and this is year 1 until 20. So what is A minus B? Okay. Okay. And that will be this one. 229. Okay. Now, so remember the MARR that we want is 6%. So MARR, minimum attractive MARR, is 6%. So the NPW of A minus B at 6% is what? So that's equal minus 2000 plus 229 times, so it is an annual cash flow. We are calculating for P, so that will be P over A, 6%, 20, and the result is 626.63, and it is bigger than 0. So we choose A. So A is the winner, so we eliminate B. So B is gone. Okay. Now let's compare A and C. So we will have the same thing here. Now A and C has a higher total, so we will have the cash flow of C minus A. C minus A. So this is year 0 and year 1 till 20. C minus A. Okay. And then that is the cash flow from year 1 till year 20. So the NPW of C minus A at 6% will be minus 2000 times 122 P over A 6% 20, and the result will be minus 600.66, and it is less than 0. So because it is less than 0, so we choose A. So A is the winner, so C is gone. Now we compare A and D. Okay, so we have here, so A having a higher total, so it should be A minus D over here, year 0, and then year 1 till 20. Okay, so A minus D okay, and then we need to calculate the NPW of A minus D at MARR, which is 6%, and that's equal minus 3000 plus 522 times P over A 6%, 20 years, and that will be 2987.34, and that is bigger than 0. So because it is bigger than 0, so we choose A. Okay, so D is gone, we choose A, so A is the winner. Now the last one, we need to compare A and E. So we're gonna have here, so A having a higher total, so it is A minus E, so 0, and then 1 until 20, so that will be minus 4000 minus 9000, that's a positive 5000. Okay, now the NPW of A minus E will be 5000 plus or minus 146 times P over A 6% 20, and if you do the calculation, the result will be 332538, and that's bigger than 0, and therefore we choose A. So E is gone. Okay, so what alternative that we use to choose? So the best alternative is alternative A. So that is it, the solution for example number 6. Now let's do the next example, which is example number 7. So there is a company that need to buy a machine, and they have 3 alternatives. Each machine has a useful life of 4 years. If the MARR is 5%, which alternative should be selected based on the incremental rate of return analysis? So we know that the MARR is 5%. So they have alpha, beta, and gamma. Okay, I will just put it over here. Alpha, beta, and gamma. Okay, so the life is how many years? 4 years. So we have year over here, 0, 1, 2, 3, 4. Sorry. So alpha, the initial cost is 15,000, so this is minus 15,000. Annual net benefit is 4329. Beta 22,000. Annual net benefit 6060. Gamma 24,500, and that is 7020. And this is those value happen from year 1 till year 4. So 1 until 4. Okay, now the next information that we have is the IRR. So the IRR of alpha is 6%. This is 4%, and gamma is 5.7%. The MARR equal 5%. Now we have the information of IRR. So we know that the highest IRR is 6%, and that belongs to alpha. Should we choose alpha? No. Remember, because we have MARR, we will have that intersection point between 2 alternatives. Okay, when the value of MARR less than the delta IRR, we choose the alternative that give you this is what is L, the lower total. But when your delta IRR is bigger than your MARR, then you choose the alternative that give you the lower total. Okay, sorry, the higher total. So in this case, because we have MARR, we cannot conclude or make a selection just based on your IRR. So what we need to do, we need to do the incremental analysis. But now see, alternative beta, the IRR is 4%. So beta IRR equal 4%, and that is less than the MARR, which is equal 5%. So we want at least 5% rate of return, but beta give you 4% rate of return. So eliminate beta right away. So now the thing that we need to do is comparing alpha and gamma. So we will calculate the total cash flow. So the total cash flow of alpha is minus 15,000 times 4 plus 4 times 4329. Okay, so sorry, this should be a negative value because it is an initial cost. So gamma has the higher total, so we need to calculate the NPW of gamma minus alpha at MARR, which is 5%. And what we will have, I need to calculate that first. So gamma minus alpha, and that will be, okay, so that is the difference between gamma and alpha. So the NPW of gamma minus alpha at 5%, that will be minus 6500 plus 2691 times P over a 6% 4, and that will be 4286, and it is bigger than 0. So because it is bigger than 0, so we choose gamma. So I think that is it for the incremental analysis. Remember, in the example, the interest factor that I have, it is just P over A, but it can be P over G, it can be F over P, and whatever it is, it can be anything. But in this example, I'm just using P over A. However, it can be anything, and I think that is it. Thank you very much.